Okay, so we're going to do this differentiation. I'm doing this question, which is from 2005, paper 3, as question number 9 of differentiation. So you're given a curve is like this, and there's a maximum point on the curve, which is M. The diagram shows part of the curve, which is y is equal to x over x squared plus 1, and its maximum point M. The shaded region R is bounded by the curve and by the lines y is equal to 0 and x is equal to p. Part 1, calculate the coordinates, x coordinates of M. So once we have to calculate the x coordinates of M, we know that at maximum point, which is over here as M, we know that the gradient at this given point would be 0. So over here, since this point is the maximum point, we know that dy over dx at any stationary value or turning point, the dy over dx, the gradient is 0. And that's the equation given to us right over here of y. So the y equation is y is equal to x over x squared plus 1. That's the y equation. So the first thing we need to do in order to solve this, we need to differentiate this so we get dy over dx and equate it to 0 and solve it for x. That's going to give us the first part, calculate the x coordinate of m. Yeah, only the x coordinate of m. We don't need the coordinates of m, x and y, no, only just the x. So let's get ahead with this question. Question number 9. The equation was y is equal to x over x squared plus 1. If you notice over here, this is in the form of y is equal to u over v, which is the quotient rule, which we did in maths. So that is dy over dx, which is v into u dash minus u into v dash, whole thing over v squared. So first, whatever's on the top, that's taken as u. Whatever's in the denominator, that is v. So we write the values first. U is equal to x. U dash is basically the differentiation of u, which is du over dx. If I differentiate u with respect to x, I'll just get 1. V is the denominator, which is x squared plus 1. If I differentiate, v dash is basically dv over dx. So I'm differentiating v with respect to x in this given equation. If I differentiate this, I get 2x, and that's all. So I have all the 4 things that I need in order to substitute in this formula. So now I have dy over dx is equal to, all I'm doing is substituting the values. V first, it's v times u dash. So v is x squared plus 1 times u dash, which is 1, minus u, which is x, times v dash, which is 2x, whole thing divided by v squared, and v is x squared plus 1, whole thing squared. We do not have to expand this. Why? Because we are finding the x coordinate of the maximum point, which is a stationary point, and at the stationary point we know that dy over dx is 0. So once we have dy over dx is 0, I can replace this dy over dx over here as 0 is equal to the whole given equation, which is x squared plus 1 times 1 is the same thing, minus x times 2x is 2x squared, whole thing divided by the denominator, which is x squared plus 1, whole thing squared. Now if that cross multiplies with 0, it just becomes 0. So you get rid of the denominator, and your equation, the simplified equation, becomes x squared plus 1 minus 2x squared is equal to 1. So I'll leave 1 over here. I'll take these 2 on the other side. I have first simplify them over here. So x squared minus 2x squared, that gives me minus x squared. That taken on the other side gives me x squared. So x squared is equal to 1 under root both sides, I get xs plus minus 1. Since if I see the graph, I have the x value on the positive x-axis. So x value is taken as 1. So that's my part 1 answer, where x is equal to 1. We just have a look at the question, and then you can see the x coordinate is on the positive side. So if we go back to the question right over here, see the maximum point of m is on the positive x-axis. So we got two values of x is equal to -1 and +1. So x over here in this case has to be +1, since this is the coordinate of m. So that's part 1 done. Part 2 is find the area of R in terms of P. So that's area under the graph, and the curve is this. We have to find area under the graph for this given curve, and we have to apply the limits from 0 to P. So we'll do this. Part 2. Same question, part 2, question number 9, part 2, the area. The formula for area is area with the limits applied of b and 1, b and a. The high limit is b, the lower limit is a, y dot dx. That's what we do. The y equation is given as y is equal to x over x squared plus 1. And a is 0, the lower limit, and b is given as p. That's given in the question, and we can see the a is 0 from the given equation, from the graph in the question. So we have area is equal to integrating with limits of p and 0, integrating the equation y, which is x over x squared plus 1 dot dx. For these type of questions where the denominator of the power is 1, remember we use ln. How do we integrate ln? We have integrating the function, whatever the function is. So if we have 1 over fx dot dx, and we integrate this, we get ln modulus fx, write the same thing, over 1 over the derivative, the differentiation f dash x. This is what we get. And if there are no limits applied, in this case there are limits applied. If there are no limits applied, then of course you get plus c. Now if we do this, so we're integrating this. If I integrate this, this is x already over here. That's fine. I get ln. I have x squared plus 1 divided by, if I take differentiation within the bracket, differentiate this, x squared plus 1, I get 2x. So that's divided by 2x, x and x cancels out. So basically what I'm getting is, I'm getting area, and now the limits I have to apply is p and 0. So I am getting 1 over 2 ln bracket x squared plus 1 with the limits applied of p and 0. Now if you notice over here, that's just a constant, that's just a number over half. So I've taken it outside the limit. So there's no point in taking it inside. It's not going to change anything. It's going to have the same meaning. So I've just taken this outside to make the calculation simple. Now what do? We just simplify this and apply the limits. So we get area is equal to half, bigger bracket, applying p first. So we get ln p squared plus 1 modulus and minus ln, so that's 0 squared, which is 0, plus 1, so that's just 1, and ln 1 is 0. That whole gives you 0. So 1 minus, as minus 0 is just this 0. So it's just this part we are left with. So it's a is equal to half ln p squared plus 1. And that's the answer to part 2. Part 2, find the area of R in terms of P. That's what we have done, and we have got that. Hence, calculate the value of P for which the area of R is 1, giving an answer correct to 3 SF, 3 significant figures. And that's just a continuation to the second part. That's why this is of 2 marks and this is of 3 marks. So you already have done this. So all you have to do is just substitute the value of area, because now area is given to you and you have to find, and you have to solve this in terms of P. So area is given to you, that R, you have to find the area when the area is 1. You have to find the value of P when area is 1. So you have, I'm just copying this again, what the answer that we got, half ln P squared plus 1. So when area is given as 1, solve for P. That's what we are doing. So area is 1 is equal to half ln P squared plus 1. This 2 goes over there, multiplies by 1, we get 2 ln P squared plus 1. Now if we're taking E on both sides, so this is 2, and I need to get rid of this ln, so I take E on both sides, so this just becomes E to the power 2. So that gives me E to the power of 2 is equal to ln E ln P squared plus 1. So that ln E or E ln, that gives me 1. So this E squared is equal to P squared plus 1. Take that on the other side, I get E squared minus 1 is equal to P squared. So the value of P that I'm getting is, I'll just rewrite this over here. P squared is equal to E squared minus 1. So I need to take under root on both sides. So I get P is equal to under root E squared minus 1 plus minus. And since this has to be a positive value, it cannot be negative, because we will get exponential, and ln cannot have any negative value. So it has to be a positive value for P. So the answer would be just this, E squared minus 1. That's all. And if we solve this, as if the question says, right, give your answer in exact form. So that's in exact form. But if it doesn't, then you can find this to 2SF. What does the question say? Let's read the requirement of the question again, I think. Hence, calculate the, yeah. So it says giving your answer correct to 3SF. So we have to work it out. 3SF, and that would give you 2.5276. So that is 2.53 would be 3SF. 3SF. So that's done. That's question number 9 done.